Alright, in this video I'm going to show you how to differentiate logarithmic functions. So let's start with an example, y equals log base 3 of x. I want to find dy dx. Remember that dy dx is just y prime. So we're looking for y prime. To get y prime from this, I'm going to start by rewriting it in terms of exponentials. So if y equals log base 3 of x, that means that 3 to the y is equal to x. So I'm going to find dy dx using this implicit relation between y and x by using implicit differentiation. So I'll differentiate both sides with respect to x. Okay, d dx of 3 to the y is 3 to the y times the natural log of 3 times the derivative of y. And d dx of x is just 1. So we have 3 to the y times the natural log of 3 times y prime is equal to 1. We'll isolate y prime by dividing by 3 to the y times the natural log of 3. Okay, here the 3 to the y times the natural log of 3 cancels, so we have y prime is equal to 1 divided by 3 to the y times the natural log of 3. Okay, but remember, 3 to the y is just x, so we can replace this 3 to the y with x. So what we have here is that y prime is equal to 1 divided by x times the natural log of 3. Or another way of stating that is that the derivative of log base 3 of x is equal to 1 divided by x times the natural log of 3. Okay, we can generalize that result. And the way we will prove it is using the same method. So we have for values of a greater than 0, the derivative of log base a of x is equal to 1 divided by x times the natural log of a. So as another example, if I want to differentiate log base 1/4 of x, it's going to be 1 divided by x times the natural log of 1/4. Okay, using this result, we can actually come up with a formula for the derivative of the natural log of x. Why don't you press pause while you work on that? Well, the natural log of x is really the logarithm with the base of e. So to use this formula here to differentiate the natural log of x, we just use e in place of a, because that's our base. So we get 1 divided by x times the natural log of e. Well, this is fine, but the thing is we can simplify the natural log of e. The natural log of e is equal to 1. So the derivative of the natural log of x is 1 divided by x times 1, or just 1 divided by x. Okay, so the two differentiation formulas I wanted you to get from this video is that the derivative of log base a of x is 1 divided by x times the natural log of a, and of course our base a has to be greater than 0. Also, the natural log of x, its derivative is 1 divided by x. Okay, I forgot to mention here that also a cannot be 1 because 1 is not an allowable base in a logarithmic function. Okay, let's just do one example where we use the chain rule together with one of those formulas. Press pause while you work on the derivative of this function. Okay, so log base 6 of x is the outside function. So we take the derivative of the outside and plug in the inside. So the derivative of the outside is going to be 1 divided by x times the natural log of a, but in place of x, we put the inside function. So it's 1 divided by x squared plus the sine of x times the natural log of the base. And then we take that whole function times the derivative of the inside. Okay, the derivative of x squared plus the sine of x is 2x plus the cosine of x. So therefore, the answer is this quantity times this, or 2x plus the cosine of x divided by x squared plus the sine of x times the natural log of 6. Okay, so quick recap, what did we do here? We put 1 over the inside times the natural log of this number. We multiplied that quantity by the derivative of the inside. Okay, so 1 divided by the inside times the natural log of the base times the derivative of the inside.